left. And I'm not going to lie to you, this lesson is rather weird. It's not super difficult. There's a lot of stuff, so you're going to have to calculate on your calculator, but the math itself is pretty simple. So just pay attention, and you will be just fine. All right, so measures of variation. That is what we're talking about. Measures of variation. We've talked about measures of center. That would be your mean, median, your mode. Measures of variation are like how spread out they are. Okay, we are going to talk about two measures of variations, two different kinds. We're going to talk about standard deviation. We're going to talk about mean absolute deviation. So this is a picture of a perfect bell curve. What I mean by perfect is like, here is your mean, and everything is symmetric on one side as it is on the other side. And so, you know, for every measurement between 55.2 and 66.3, there's the same amount between 33 and 29.9. This is one standard deviation, and I'm not going to lie. A standard deviation is a very, very difficult calculation. We're going to talk about standard deviations. We're going to use standard deviation, but we're not going to calculate it, because that is an equation you are incapable of until you probably take calculus, or at least statistics, okay? So first, let's go over here. We're going to be talking about mean quite a bit. So remember, the mean of something, we're going to have to calculate that, is adding all of them up and dividing by the number that we have. So in this first problem over here on slide number 2, we've got a sample. A restaurant asks the staff to record the number of people who order the special each day. And the table shows the number of specials ordered that day. So day 1, day 2, they only did it for 6 total days. So to find the mean of the set, we're going to take those 6 totals, 26, 25, 30, 32, 27, 28. We're going to add them up. And then we're going to divide by how many we have. Well, we have 6 of them. So 26 plus 25 plus 30 plus 32 plus 27 plus 28, and then take that total and divide it by 6, because there are 6 of them. Okay, so I get a mean of 28, no decimal, which is kind of nice. Okay, so then we're going to take this table and we are going to find the difference. So finding the absolute value. So I don't care if it's positive or negative. I don't care if my number is higher than the mean or lower than the mean. I just want to know how far away from the mean it is. I need a positive answer. So how far away? 28 is our mean. So how far are each of these numbers away from 28? So 26 is 2 below. 25 is 3 below. Notice I don't care if I'm below or above. It's positive. 30 is 2 above. 32 is 4 above 28. 27 is 1 below. And 28 is the mean. So that's going to be 0. All right. So we found the difference that each of our number was away from the mean. So how far away each one was from the mean. So now we are going to actually find the mean of those numbers. And we call that the mean absolute deviation. So find the average of the values for the difference. So 2 plus 3 plus 2 plus 4 plus 1. And I know you have that 0, which doesn't change your total, but you still have to divide by 6. So this one's super nice and pretty. It's 2. They're not going to usually be that pretty. Okay, so what we just calculated was the mean absolute deviation. All right, and we are going to have to write sentences describing that mean absolute deviation. So let's go down here and first of all talk about that. So the mean absolute deviation is just right here, the average distance between each data value and the mean. Now, it doesn't mean every data value is exactly 2 away from the mean, but that's the average distance that each value is from the mean. So when we write a sentence, we're going to write something similar to that, only instead of saying data value, we will actually use the term of what it is that our numbers represent. So a couple steps. 1, find the mean. So add them all up and divide by the total. Step 2, find the difference between each value in the data set of the mean. Now it says absolute value because I don't care, as I said, if our value is below the mean or above the mean, or it's all positive numbers. That's what the absolute value means. And then find the average of those values. So that's your mean absolute deviation, and write a sentence. So let's do this over here first for this first example, okay? here we go. We have a table of all the people, 8 people, not all the people, people in standing line for the roller coaster, standing in line, and there are their heights in inches. So first of all, find the mean absolute deviation and then describe what it means. Okay, so to find the mean absolute deviation, the MAD, we have to start with finding the mean. So let's add all those numbers up. There are 8 of them. So 52 plus 48 plus 60 plus 55 plus 59 plus 54 plus 58 plus 62. And I get a total of 448. I'm going to divide that by 8 because I have 8 values. So for my mean, again, nice, I don't have a decimal, so that's awesome, 56 inches, right? So the average height of everybody in line is 56 inches. Okay, so now it says, find the absolute value of the differences. How far away? So I'm just going to go up here, 52. How far is 52 from 56? It is 4. How far is 48 from 56? That's quite a bit lower. That's actually going to be 8 away. 60 from 56 is 4. 55 from 56 is 1. 59 is 3 away. 54 is 2 away. 58 is also 2 away. And 62 is 6. So I should have 8 values here. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to total them up. So 4 plus 8 plus 4 plus 1 plus 3 plus 2 plus 2 plus 6. So 30. So how do I find that average? I take 30 and divide it by 8. This one is not going to come out nice. But I'm going to leave it alone. I'm going to leave it 3.75. Okay? So the average distance each person's what is from the mean height is what? So the average distance that each person's height, because that's what our measurement is giving, is from the mean, and that's underlined because the mean was 56. The mean height is 3.75 inches. The average distance each person's height is from the mean is 3.75 inches. All right, flip this baby over. Now that's the mean absolute deviation. We can calculate that. It is just finding the mean, finding how far everything is from the mean, and then finding the mean of those values. So that is everything you are capable of calculating. All right, so let's try one more. This one's nice and easy. They only give us 1, 2, 3, 4, 5 numbers. The number of points that Samantha scored in 5 basketball games: 8, 14, 10, 7, and 13. Find the mean absolute deviation and then describe what it represents. So number 1, the mean. We have to add them all together and divide by 5. So 8 plus 14 is 22. Let's see. 8, 14, 10, 7, and 13 should be, yep, 52. So 52 divided by 5 games is 10.4. Now this one's not as pretty, right? Not quite as pretty. Let me just double check to make sure I didn't make a mistake. 8 plus 14 plus 10 plus 7 plus 13. Yep, divided by 5, 10.4. All right, step 2, we got to find the distance that each one is away from 10.4. So 8 away from 10.4 is 2.4. 14, now be careful. 14 minus 10.4 is going to give me 3.6. All right, 10 away from 10.4 is 0.4. 7 away is 3.4. 13 is 2.6. 1, 2, 3, 4, 5. So that's finding all the distances. Now I'm going to add those all up. So I've got 2.4 plus 3.6 plus 0.4 plus 3.4 plus 2.6 gives me 12.4 divided by 5, which is 2.48. Now, that's points. That's the average distance that each total is from the mean. All right, so this is what we're going to say. Look back here. So the average distance, I'm going to refer to these as game totals. The average distance that each game total is from the mean is 3.7. Oh, sorry. I was thinking the other problem. 2.48 points. The average distance that each game total is from the mean is 2.48 points. Okay, we're almost done. Now, standard deviation is, as I said before, much, much more difficult to calculate. It's so difficult to calculate that you won't calculate it. They will give you a standard deviation. So what you will need to calculate is the mean. So you'll find the mean, and all you will do is take the standard deviation and you will subtract it from the mean, and you will add it to the mean, and those are the values you will get. And then you will say that all the values between this one and this one is within one standard deviation from the mean, because that's either one standard deviation below or one standard deviation above. Okay, so write a sentence. Excuse me. So first find the mean, then find the range by subtracting and adding the standard deviation, and then you're going to write a sentence. So all the values between 17.5 and 24.5 are within one standard deviation of the mean. Okay, so let's